The length of a piece of wire is 40 centimeters. It is cut into two parts, each of which is then used to form a square. Part 1. If x centimeters is the length of a side of one of the squares, find the length of a side of the other square in terms of x. So if we draw out a square and we label one of the sides as x, because they tell us in the question x centimeters is the length of a side of one of the squares. Well, if this side is x centimeters, then the other three sides are also x centimeters. And x plus x plus x plus x is 4x. So the perimeter of the square of side length x is 4 centimeters. So the perimeter of this particular square here is 4x. So the remaining length is 40 minus 4x. So remember, we were given 40 centimeters for the piece of wire. It was cut into two parts. It wasn't necessarily cut into two equal parts. It was cut into two parts. One of those parts is used to make the perimeter of this square. So one of those parts is 4x. And the remaining length, or the leftover part, is going to be the 40 centimeters minus the 4x. So the remaining length is going to be 40 minus 4x. Now this remaining length, 40 minus 4x, is the perimeter of the entire other square. And remember, a square has 4 equal sides, so each side must be the same. So the length of the side of the other square is going to be a quarter of this. So this is the remaining length of wire. So dividing it by 4 or multiplying it by a quarter will give us the length of one of the sides of the other square. So a quarter times 40 minus 4x is going to be 10 minus x. Or you could have just divided this by 4. So 10 minus x is going to be the length of one of the sides of the other square. And all the sides, the 4 sides of the other square, will also be 10 minus x. Part 2. Hence, write down a formula for A, the sum of the areas of the two squares where A is in centimeter squares. So first of all, when we see hence, it means using an answer from the previous question. So the area of the sum of the two squares is going to be area equals length times width plus length times width. So length times width gives us the area for one of the squares, and length times width gives us the area for the other square, and we need to add them together because sum means add. So the first square that we were given has a side of x and another side of x. So x multiplied by x, length multiplied by width, gives us x squared. So length multiplied by width gives us x squared. Then we add that to the area of the other square. And remember, the side length of the other square was 10 minus x. I'm going to draw this out so we can see it. So the length of the other square is 10 minus x, and the width is also 10 minus x because it's a square. And 10 minus x multiplied by 10 minus x, so length times width, gives us 10 minus x to be squared. So multiplying out 10 minus x to be squared, we get 100 minus 20x plus x squared. And we just bring down the x squared that we already had from the other square. And then simplifying, x squared plus x squared is 2x squared minus 20x equals 100. So here we have a formula for the area of the two squares added together. Part 3. By making a table of values for x values greater or equal to 0, less than or equal to 10, so basically x values from 0 to 10, sketch a graph of A against x. So we have to use our formula that we created in question 2, which is area equals 2x squared minus 20x plus 10 plus 100. And we're going to sub in x values from 0 to 10. So we get 0, 100. So subbing in x into our formula, we'll get 100 as our y value. 182, 268, 358, 452, 550, 652, 758, 868, 982, and 10, 100. Now the quick way to do this is to use the f of x function on our calculator, so the table function. So then we plot our points on our graph. So our x-axis represents length in centimeters. So that's the x-axis there from 0 to 10. And our y-axis represents area in centimeters squared. So our y values go up as far as 100. So this is what our graph looks like, and it's what we would expect because it's a positive x squared, so it should be a U-shaped graph. It's a quadratic graph. And notice that we have our constant at the end as plus 100, and that is where it crosses the y-axis. Part 4. Use your table and your graph to find the least possible area enclosed by the two squares and the value of x for which this occurs. Then check your answer by completing the square. So from the table and the graph, the least value of a is 50. So we can see in our table, 50 is the lowest a value or the lowest y value. And we can also see in our graph that the minimum point of our graph is about 50. And this occurs when x is equal to 5. So there's an x value of 5 when we have a value of 50 or a y value of 50, and an x value of 5 when we have an a value or a y value of 50. So now we have to check our answer by completing the square. So when we complete the square, we end up figuring out what this minimum point of our curve is. So we have a equals 2x squared minus 20x plus 100. So we want to complete the square, but we cannot use the complete the square method when we have 2x squared. We can only use it when we have x squared. So we can multiply across by a half, or you could say that we are dividing across by 2. So we end up with a half a equals x squared minus 10x plus 50. So each of these values has been divided by 2, and we have multiplied the a by a half. So next we're going to get the constant over to one side. So at this point it doesn't matter if you have your x squared and your x on the left or your x squared and your x on the right, so long as they're together. So in this particular example, we're keeping the half a on the left and bringing the plus 50 over the equal sign to become minus 50. So that we have the x squared and the minus 10x on the right. So you want to get your x squared and your x together and everything else over the other side. Next, we're going to add half the coefficient of x to both sides. So our coefficient of x is minus 10, half of that is minus 5. So we add minus 5 squared to both sides. Make sure you use brackets. Minus 5 squared is 25. 25 minus 50 is minus 25. We bring down the x squared, the minus 10x, and again minus 5 squared is 25. Now we factorise the right hand side. Sometimes you're factorising the left hand side, it just depends on which way you arranged your equation. So factorising x squared minus 10x plus 25, we get x minus 5 times x minus 5. So this is a plus, which tells us these signs are the same. This is a minus, so they're both minus. And the factors of 25 that will add together to give 10, or in this case minus 10, is minus 5 times minus 5. So minus 5 times minus 5 is plus 25, and minus 5 gives us minus 10. Now x minus 5 times x minus 5 is x minus 5 squared. And again on the left we had a half a minus 25. So now we're going to bring the minus 25 over the equal sign, it becomes plus 25. And we're nearly there, we just have to get the a on its own. So at the moment we have a half times a, so a half a is a half times a. So we're going to multiply across by 2 so that this will cancel out. So a half times 2 is 1, so you'll end up with 1a. So we have to multiply everything by 2. So x minus 5 squared becomes 2 times x minus 5 squared. You do not multiply the 2 into the brackets, you leave it outside the brackets. and 25 times 2 is 50. So the minimum value of a is 50, or sometimes we call it y, and this occurs when x is equal to 5. So the minimum point on our graph, we can see, is at 5, 50. So our x value is 5, our y value or our a value is 50. So the number at the end here, the constant, that represents our y value of our minimum point, or in this case our a value, so that's 50. And we have x minus 5 inside the bracket, so we'd have x minus 5 equals 0, so x would be equal to positive 5. So our x value is 5. So our minimum point on our graph is 5, 50. So in general, you can just learn off that your x value will always be inside the brackets, you just change the sign, and your y value, in this case our a value, will always be our constant. Part 5. Use mathematical tools, table, graph and algebra to estimate the values of x for which the sum of the areas of the squares is 75 centimeters squared. So from the table and the graph, we estimate that a is equal to 75 when x is equal to 1.5 and when x is equal to 8.5. So looking at our table first of all, so 75 is going to be somewhere in between 82 and 68. So therefore your x value is somewhere in between 1 and 2. We're going to estimate 1.5. And our other x value is going to be in between 8 and 9. Because again, 68 and 82, 75 is in the middle of those. So 8.5 we're going to go with for x values. Looking at our graph, what we do is we go to 75 on our a-axis, that's about 75 there. We draw a line across, and the 2 points of intersection we drop perpendiculars. So that's about 1.5 on our x-axis, and that's about 8.5 also on our x-axis. So that's using the table and the graph. Now we want to use algebra. So we take our equation, 2x squared minus 20x plus 100, and we let it equal to 75. We then bring the 75 over the equal sign, so 100 minus 75 is 25. And at this point you will not be able to factorize, so we're going to solve. And we're going to solve using the minus b formula. So our a is 2, our b is minus 20, and our c is 25. So this is our quadratic equation formula. We substitute into the formula. So we get 20, so this would have been minus 20, plus minus the square root of 400, which would have been minus 20 squared, minus 4 times 2 times 25, all divided by 2 times 2. That gives us 20 plus minus the square root of 200 over 4, which gives us 1.46 or 8.54. So these are our exact values rounded off to 2 decimal places. And we can see that they were indeed very close to our original guesses. 1.5 is very close to 1.46 and 8.5 is very close to 8.54. Very important to note that if you're ever told to use your graph, you want to actually draw on your graph.